Hi, this is for that example 511. Um, they have a nice balanced equation there. Three oxygen gas molecules get together to make two ozone gas molecules. And the enthalpy change for that reaction is 286 kilojoules, which means it takes 286 kilojoules of energy to run this reaction. What they want to know is what is the enthalpy of formation for O3, ozone. That's what they want. So to get that, you need to understand the meaning of the enthalpy of formation. This is a technical thing in chemistry where the enthalpy of formation of anything is the energy involved in the equation where you make 1 mole of that thing. So we're talking about ozone here. So you need to make 1 mole of ozone, just like that. Now, not only do you need to make 1 mole of that thing, but you also need to make it from its elements in their pure forms that in which you usually find them in nature. So this guy is made of oxygen atoms. So you need to make him out of oxygen gas in its pure form, which is O2. And the way you find O2 in nature is you find it as O2 gas, right? This is, in the book, they call this the standard state. Standard state, that just means the state of matter that you find this material in nature at room temperature and 1 atmosphere of pressure. So I need to balance this somehow. But see, I'm not allowed to put anything over here. It has to be 1, and that's all it could be. Why? Because we're talking about a special thing in chemistry here, the formation, the enthalpy of formation. So this is known as the formation reaction. There is also a couple of questions like this on the quiz. I think there are 2 like this, or they might be just 1. There might be just 1. Okay, so this is the formation reaction. That means I need to put something here that will get me 3 oxygen atoms. Unfortunately, it's going to have to be a fraction. I mean, when you balance equations, you're not allowed to use fractions here as coefficients because there's no such thing as half of an atom or half of a molecule. However, for the formation reaction, you do need to use fractions here because when you do the formation reaction, you have to make 1 mole of the product. So I'm going to put 3 halves here because 3 halves times 2 is 1. Here's how I know that. 3 halves times 2 is 1. The 2's can't... Oh, I'm sorry. 3 halves times 2 is 3. Haha, sorry about that. And here's how I know that. 3 halves times 2, the 2's cancel, you get 3. 3 is appropriate because I need 3 oxygen atoms for this. There are 3 oxygen atoms in 1 ozone molecule, so 3 is what I need. Hope that made sense right there. Now, it totally doesn't make sense from a molecular standpoint to put a fraction right here on the O2. So when you write the formation equation, you just assume that we're not talking about atoms, we're not talking about molecules, we're talking about moles. In any chemical equation, you could be talking about moles, you could be talking about atoms, you could be talking about molecules. But for the formation reaction, we're only discussing moles, all right? So that's it. That's how you do it. Here, let me show you the rest of this, which is a bit trivial. So if the formation reaction requires only 3 halves, or 1.5 oxygen molecules, and the equation that they're asking about requires 3 oxygen molecules, you can easily use the oxygen, the O2, to figure out what is the delta H for this formation reaction. You don't have to use this one. You could use this one, the ozone. Here, let me use the ozone and show you exactly what I'm talking about. So I want this. It's going to be in kilojoules because it's energy. It's going to be either in joules or kilojoules. I'm going to pick kilojoules. So I want to end up with kilojoules. So let me start with something that has kilojoules. Here's kilojoules. So 286 kilojoules is for the reaction when you make 2 molecules of ozone, or 2 moles of ozone. I need to be using moles. And now that is related. I need to get rid of moles of ozone. So the other place where I find moles of ozone is right here. So for 1 mole of ozone, how much is it? How much energy is it? Moles of ozone cancel, and I get 143 kilojoules. Right? So that goes right there. All right. Now, you could have used the ozone. You could also have used the oxygen. Let me show you how to do this with the oxygen. Okay. So with the oxygen now, I want kilojoules. So let me start with kilojoules. This is kilojoules, 286 kilojoules, and this is for reacting 3 moles of oxygen. So 3 moles of oxygen gas, O2. But I want the answer of this, which is associated with this equation, and this equation only has 3/2 moles of oxygen gas. So 3/2 moles of oxygen. So the moles of oxygen cancel out. I get 286 times 3/2 divided by 3. So that's 286 times 3 over 2 divided by 3. Dividing by 3 is just like multiplying by 1/3. The 3's cancel. So 286 divided by 2 is again 143 kilojoules. That goes right there. So that's how this is done. The key here, so all of this calculation is very similar to the other calculations that you have done in previous modules. The only difference is we're using kilojoules here instead of grams or moles or something. Now, what's special about this problem is the formation reaction. You just need to understand that the meaning of a formation reaction is a chemical reaction where you make 1 mole of the product that you're interested in, and you make it from the individual elements that are in this product in their standard states, meaning the way you find them under normal conditions in nature. So this is made of oxygen. The way we find oxygen under normal conditions in nature is usually O2 gas. So I need to make 1 mole of this stuff out of O2 gas. And then the enthalpy of formation is just the energy that is involved in this chemical reaction. It requires 143 kilojoules to run this reaction. By the way, it's interesting to note that this reaction is happening all the time. The UV radiation from the sun gives that 143 kilojoules to a bunch of oxygen atoms, oxygen molecules to run this reaction. But that's not all. In nature, air pollution is also involved. So this doesn't need just oxygen gas. This ozone can also be made from nitrogen dioxide plus oxygen gas. It could be made from sulfur dioxide plus oxygen gas. It could be made from dinitrogen monoxide plus oxygen gas. There are all kinds of items in air pollution that make this reaction go much more quickly than it would normally with just oxygen gas. So the ozone that we find in the atmosphere that we breathe is very harmful to us. It comes from air pollution, different molecules of air pollution reacting with oxygen gas in the presence of sunshine. But the ozone that we don't breathe, the ozone which is located high above us, where the jet airplanes go, way above the clouds, that ozone we need. That blocks the UV radiation from the sun to let us all survive here without getting cancer. Like, life on Earth wouldn't exist if there weren't ozone in the upper atmosphere, the ozone the air that we don't breathe. But that's besides the point, isn't it? Thank you for the question. Bye.